Today I'm going to be talking about the range test of the Air 3 of different speed settings, and also about how winds may affect these results that I might get as we go through the video. I did a test of about how long the drone would hover, and that was about 39 minutes and 22 seconds. Given it was slightly lower at 99, so it might be into the 40 if it was an extra 30 seconds or so. But so if you change this into seconds, the 39 minutes 22, that would be 2,362 seconds, and then you divide that by 100%, that would be 23.62 seconds. And that would be equivalent, roughly similar to what I've got on my hover results here, when I did some checking to see how long the drone would hover for, in between 22, 24.7, 25. So hover time here was 25. But if that was maintained, the 25, that would be about 42 and just over 42.5 minutes with the hover time, but obviously on average it was a little bit less. So here we have the connection, and as you can see, it's 100%, even over a few hundred meters with the Air 3. Comparing with the Mini 3 Pro, which has a few drops, it's still way better. In the UK, we use the CE mode of transmitter power, which is about 10 times weaker than that of the US's FCC transmission power, but it's adequate with the new technologies that they have on the DJI's Air 3. Should be more than adequate. The only thing that could be is trees and buildings, that a lot of interference, and your drone is very low and has things in the way. That's the only way you can have connection issues. If you're flying only a couple of 100 meters away, you should never have any real problems with the drone's connection. So for me, I got at 7, I did a slow 7.8 meters a second, and I got 13 kilometers, which is I did that at 10 meters a second with the Mini 3 Pro, and I got roughly just over to 16% with my Air 3. So doing a bit faster at 12 meters per second, which is the where the air resistance is supposed to be. So that's kind of a point where the drone, if you're on the graph will be going upwards, and then you'll hit roughly at 12 meters a second is where the resistance of the air kind of limits the actual range a bit. It will, as I'll show later on, you do get greater range if you have strong tailwinds. And in sports mode, about 21 meters per second, that was 16.6 kilometers and about 16 minutes flight. So it's still more than the Mini 3 would fly at a slower speed. Mini 3 Pro is 9 kilometers in sports mode. I tried to do at the maximum cruise speed of 15 meters a second, which is the new set cruise speed, up from 12 meters per second that it was when the Air 3 first came out, and that was 16 kilometers, which was less than the sports mode. So that actually shows that this wasn't actually the most for you getting better range in sports mode, but came out in the my results. Wanted to kind of figure out if I could get this more accurately, sort of do a distance and see what kind of range I could get with the Air 3 and how the drone performs with tailwinds, headwind and a tailwind, and what the performance would be in normal mode and sports mode, and slower than if you're only going at like 5 or 7 meters a second. What kind of range is that? So I've been taking lots of tests here to try and gain an understanding of the kind of range, what the average speed and range is of the Air 3, and what kind of data I get from doing different flights. So more data ranges, playing around with different range from UAV data, and then trying to sort of put it into something that kind of makes some sense. So one of the main things I did to try and understand is I discovered really is that battery life is sort of the kind of way of monitoring the power usage over time, and then the speed. Like if you got 9.6325 multiplied by the speed would be like 204 meters approximately. So you can see here that the time, the speed times the time does have an effect, but you also have to take into account winds. Slightly. Actual winds don't really, it's the battery life, because here for example you got quite large changes, and this is just slight variations. Here for example it's much higher and then it's much sort of lower, so you got a sudden, the average is slightly skewed because of this, when here you got for the same speed this is easterly, so I think I did this at a different time and not sure if it was a different direction. So this was definitely going westerly direction, and this is easterly. So I averaged the time and the speed. So, but this is taken directly from the average times between each depletion of battery of the percentage of battery, and the average time. So I just moved it here just to make it a little bit easier to keep track of the average, but it does vary a bit from reading to reading, because these are two readings. Now here it goes from like 5 meters a second, you've got like 27.15. If we take the hover time, sometimes it was as low as 22.3 seconds, so the hover time was not longer at all. You got 26, 24. This was, the drone was just hovering in the sky doing nothing for about a minute or 2 minutes, and I just added those just as a kind of idea of the battery life. And here you can see it actually goes way up, nearly 27 seconds, and then it sort of settles here at 24.5, and 26 goes back up again as you go up to hitting 27 seconds. So you got so that kind of, when it comes down to here and you put all those battery time, you get this kind of effect where the battery life grows, hits 27.28 and then drops, and in the end this is what it came up as. And just the slight variation, did one set in one direction with odd numbers, so odd numbers being these ones here, and then the other ones were even numbers. It gives quite a different, even this gives quite a different set from the speed. So from this, all the data I've put together, you kind of get an idea for what the average speed with very low headwinds, or so you have a increase, then you hit the kind of speed like cruise section, and then you got sports mode here with your slight, obviously there's slight variations because of different directions, and this shows the battery life with 27 being nearly 10 meters a second, and the smoother kind of effect there. So the real kind of distance is really battery life in seconds in drop of battery versus the distance that covered would give you the range. But you can never get that because I can't get the exact power level. I can never be absolutely certain on what the actual range is and get it nice and smooth, but it's kind of I think fairly close to what you would get. So if you multiply the battery life to say a full battery, you'd be getting like nearly 30,000 meters, nearly 30 kilometers, and so like this one would be 31.3 kilometers if it was sort of if you could sort of multiply the average. It's just a theoretical maximum, because obviously this would be like 27,000 at 15 meters a second, but it's just kind of given an idea, where here at 10 meters a second is actually slightly higher than the sports mode, but this is like the theoretical power. So it's just kind of trying to understand how the range and battery life all come together to kind of give you a range. This is kind of as good, and I don't think I can get any more accurate really. Over the last couple of weeks I've been taking some data, and I've sort of put a kind of data set here where I can on Excel to show how this looks. So this side we got the distance covered per every 1% drop in battery, and this was the speed. Some of these are taken at different times. This was taken the most recent with winds of between 0.5 and 2 gusts of 2 meters per second, but most of it is less than half, is only about half a meter a second, or about walking pace 3 miles per hour. Here you got 4 to 5.5 meters per second with a tailwind. So this upper one here is the tailwind. I took there's 420 meters. This is in metric system. So I got, I think, like 2 points. I think I did a little bit more on here just to make it for the farther distance, because to increase the amount of data, so I have more than one, just 2 points. So to get more than just one data point, I will get at least 2 or 3 data points when we're at higher speed. When I did this particular result more recently, I took at the higher speed I did increase the distance to get more than 1 point, because some of these, like this one here, is like 420 meters for what, just between a data point, so that's a lot of distance really. So it's just to increase the accuracy, at least 2 data points. So this one here is with the tailwind, this one's with the headwind. As you can see, it's more flat because you can't really go more faster with when you fly once you reach the speed where the air is equal to the maximum power of the drone. This one was sort of very low or no winds at all, but even so there's a slight curve where the winds are slightly got a slight tailwind and then a slight headwind. So it's also because of the limitations. I think it's like nearly 600 meters. I can't really fly that far. The line in the middle only shows as 0.8 meters a second, or for a head or tailwind. So here there's a bit, even though it didn't seem to be that windy, I was getting about 5 meters, that's about 10, 11 miles per hour headwind. So if the maximum speed is 47, it would be down into the 30, or about 15 meters per second. If you got a 5.5 meters a second from maximum speed being 6 meters, then we're talking the maximum speed as visually accounted for in my when filming was about that speed in a headwind. So the main thing to take away from these results that I did over a couple of weeks was that if you have a headwind, the drone will reach a speed and then it will basically not go any faster. So here this graph represents the speeds of the drone, various speeds of the drone with tailwinds. So here, this one, you got 4.8 starting with, if we take in the yellow line here, and it climbs to 7.46 tailwinds. So all these ones are winds, and the ones over here will be the headwinds. And obviously you can see here the slowest speed I put 11 meters a second. So we carry on with the 21 meters a second in the opposite direction into the headwind. The headwind is roughly 5.2 meters a second coming back, and then you get 4.1 meters a second, and then drops to about 2.2 meters a second. As you can see, the yellow climbs up there to the top. There's a variation as each of these readings get different winds, and the tailwinds you can clearly see are higher, but they give quite a lot of variation in speed. Pinkish 11 meters a second being the wind speed, which remains more or less constant throughout, with only just a drop where I think I stopped the flight at one point, but that shows the results there. So the Air 3 has a top speed of 47 miles per hour. So if it flies into a 20 mile an hour wind, its maximum speed will be 27 miles an hour, which it could fly into the headwind in sports mode, and it wouldn't be able to fly faster than that. Let's say that there was a 31 mile per hour headwind, and so we were flying into the wind. So that would mean we would be doing like 16 miles per hour, which would be the maximum speed that the drone could move into the wind. So if we take in how much theoretically the battery would use and get the range you'd get with it. So 9.5 seconds per drop in 1% of battery would, at 7.1 meters a second, would give 67.5 meters. That would eat like 10% of the battery, just doing 675 meters into 31-mile-an-hour wind. So if you have strong winds, you're going to, if we calculate like 10 seconds in every drop in the battery life, you'd be getting like 13 minutes of flight time in the really strong winds. So if we take our best time results of depletion of 1% of battery at 15 meters a second, that would be about 29,000 for a full battery. So that would be kind of the maximum range at no real headwinds or tailwinds. So if I summarise what these graphs show here and how how the performance of the Air 3 works. From the graph at the top here, you can see that the most efficient speed would be with a tailwind if you're coming back in the direction. So you get more range in terms, but it also shows it uses less power because you get flying with the tailwind. So if the winds are low, normal mode would be the best, with 15 meters a second being the optimum speed. If you don't have any strong gusts or winds, just sort of gentle breezes. There's no real advantage of flying into a headwind any distance, as the drone will only be able to go as fast as it can put power into the wind. So if it's using the maximum power and you're still only reaching like 10 or 12 meters per second, then the range will always be, here for example you've got around between 200 and 150 meters per second between a 1% battery drop. So if you've got a strong wind, the drone's going to have less time in the air. If you found this interesting, please give a like, and this ends the video.